Okay, so let's use our resistance wire in a simple circuit and investigate the effect of resistance. So I've drawn the start of that circuit, which might be the same as usual, a cell, a switch and a bulb. But why is the bulb there? Well, if we're going to be able to investigate what effect this has on the electric current flowing, we have to be able to see something. Now, we can't see electricity, but we can see the effect we're having if we've got a light bulb, because the light bulb at the moment, it's either on or it's off. What effect is this resistance wire going to have on the light bulb? So the light bulb's really important. We can't simply take a cell and then join it to our resistance wire, because there would be no benefit at all in that. The electric current would be able to flow directly through and there's nothing to observe. With a buzzer we would hear a sound. With a light bulb we would see the effect of the light bulb glowing, and with a motor we would see motion. So we've got some possibilities here, but simply directly connecting it is not one of them. So that's not the way to do this experiment. So let's give it a try. So let's have our light bulb. And then we'll take the switch so we can control our circuit and know it's switched on and off. Remember, the switch is a great way to begin with, just to check everything. So if we simply connect up the switch and the lamp together, there we go, on, off, we know everything's working. So now let's make a gap in the circuit and connect up our resistance wire. So a systematic way to do this would be to keep one connection still, but then allow us to touch the other connection wherever we want on the resistance wire. So there we are, we're clipped there, and the wire is 60 centimeters long. So obviously what we could do straight away is say, well, let's go for the full 60 centimeters. There it is. Now this is strange because I'm sure that switch was switched on, so let's try. No, that's off. That's on. It looks as if the long wire is simply stopping the bulb from lighting up. So we found out something straight away. Let's just check. Let's take the switch out completely so we know there's no interference at all. There's nothing in the way. Yeah, it's still the same. Well, to take this further, what we'd have to do now is say, well, if this much wire seems to stop the light bulb lighting up, what happens if we have less wire? And the way to do this would simply to go along and clip on one at a time and then observe what's happening to the light bulb. So I'll let you do that, and maybe after that you could look at, well, instead of the light bulb, we've found out about the light bulb and the effect of the resistance wire. What about the motor? You might want to make a prediction about the motor after you see the light bulb. So give that one a try, using the resistance wire in a circuit. Now, just to get the terminology correct here, we are using a series circuit to investigate the electric current flow through a resistance wire in a completed circuit. So it's not complete at the moment, it is complete now, and the bulb is helping us find out about the electric current flowing in this circuit. So I haven't shown you the full experiment. It's up to you to try it by touching and clipping on the crocodile clip ever nearer the original crocodile clip until you're actually touching the two together, and then what effect is that having?